welcome back. Today we're going to be talking about box plots. We've talked about box plots before when we talked about constructing box plots, but now we're going to be analyzing them. So let's go ahead and take a look at example A. So here we are at example A, and we're going to be identifying the data points that it asks. And it's asking us for the median, upper extreme, lower extreme, upper quartile, low quartile, interquartile range, and mode. So we're going to be doing a lot of things here. Let's start with the median, which we know is this line here in the middle. That line in the middle here is between 61 and 62, right dead center. So that's going to be our median is 61.5. Our upper extreme is the highest point on our graph here, so we've got 66 as our upper extreme. Our lower extreme is the lowest point on our graph, so that's going to be 59. Now we need the upper quartile. When we're talking about the quartiles, we're talking about the edges of the box. So the upper quartile right here at 64. Then we're at the other edge of the box. The lower quartile is 60. Now we need to do some math to find the interquartile range, which means we're going to subtract the upper quartile, 64, and we're going to take the subtraction of 60, the lower quartile, so 64 minus 60 is going to give us 4, so our interquartile range is 4. Then we need to do our range, which means we're going to take our biggest number, 66, minus our smallest number, 59. 66 minus 59 is 7, so our range is 7. And now the next thing it's going to ask us to find is the mode. But unfortunately, we're going to be taking a look at a box plot here. We can't really tell which number comes up the most. So we cannot answer this question. Anytime that you have a box plot, you cannot find the mode. So now that we know the different data points that we have here, let's see if we can answer some more questions about this graph. So continuing to take a look at this graph, it says the box plot above represents 30 students and no one is the same height. So in our graph here, every data point is going to be different. So there won't be two 66s, for example. Everybody's going to be a different height. So question 1 says, how many students are taller than 61.5 inches? So we know that 61.5 is our median, which equals 50% of our data, right? So if we know that half of the people are going to be at 61.5 or below, the other half will be at 61.5 or above. So since we're talking about 30 students, we're going to divide that in half. 30 divided by 2 is going to be 15. So we're going to have 15 students are going to be taller than the median because the median is the middle. Number 2 says, how many students are shorter than 60 inches? So we're taking a look at our 60 inches on our graph. We can see that that's the lower quartile. So the lower quartile is going to represent 25% of the data between that and the lower extreme. So we're going to be trying to figure out what 25% of 30 is. We can do this one of two ways. We can take our 30 and multiply it by 0.25. That would be the fast way. Or we can make a proportion where it says we don't know how many students out of the 30 students we're looking for, but we know that 25% out of 100 is what we're looking for. Either way will get you the correct answer. Since my interest here is speed and not my ability to solve proportions, I'm going to just do the simple multiplication. So 30 times 0.25 is going to give me 7.5, but that is a problem because I cannot have half of a student. So I need to make sure that I'm going to round up in this case so that I'm going to use rounding. I know that I can't have half a students, so my 7.5 is going to become 8 students. So the answer to that question is 8. Remember, we're talking about word problems here, so we need to have word answers every time. Number 3 says, how many students are taller than 64 inches? So again, our 64 is the upper quartile here, and we know that we can find this two ways. As we talked about again, we're looking for 25% of the data. So 25% times 30, so 30 times 0.25, or again, we can make a proportion, but it's going to be the same as the other one, 7.5. And we know that we have to round up because again, we can't have half a student. That's not how that works. So we're going to have 8 students again in this case. The last question that we have here says, how many students are taller than 66 inches? We can see here that the upper extreme of our data is 66. So 0 students are going to be taller than the tallest person that we have in this class. So 0 students is the answer there because it's asking for a number that is taller than our upper extreme. So it cannot be correct. Now let's take a look at example B. Here we are at example B, and it says the number of points 2 basketball teams scored and summarized in these box plots below. So point A's team is above, team B's points are below. Team A scored a different number of points in each of the team's 14 games, so that's important information. Team B scored a different number of points in each of the team's 13 games. So we have 2 questions to answer. Number 1 is, what is the total number of games that both teams A and B scored 55 points or more? So let's go ahead and take a look at our graph, and 55 points is going to be right here on our graph. So now we need to determine how many points Team A scored above that mark and how many games Team B scored above that mark. So let's start with Team A. So team A, we can see that 55 is going to be at its lower quartile. So that means that our data below that mark is going to be 25%, and the data above that mark is going to be 75%, because remember, each quartile represents 25% of the data. So now we know that we're going to be looking for the 75%. So we're going to take our 14 games and multiply that times 0.75. When I do that, I'm going to get 10.5. Now, that's an issue because I can't have half a game. That's not how things work. So again, I'm going to have to apply my rounding up to 11 games. So team A, we're going to go with they have 11 games. Now let's take a look at team B. So team B, the 55 mark is their median, which means 50% above is what we're going to be looking for. And there's also 50% below, but that's not what we're going to be looking for. So we're going to take our 13 games and multiply it times 0.50 to represent our 50%. When we do that, we're going to get 6.5, but again, we can't have half of the number of games, so we're going to have to apply our rounding. So 6.5 is going to round up to 7 games. So now we're going to add our totals together. So our 11 games for team A, our 7 games for team B, and we're going to get 18 games. Now let's take a look at number 2. Number 2 says, what is the total number of games that both teams A and B scored above 65 points or more? So again, we're going to take a look at our mark on our graph, and we're going to go with 65, which is right here between the 60 and the 70. So again, starting with team A is going to have above that mark the upper quartile, so we're going to have 25% of the data this time. So we're going to take our 14 games and multiply it times 0.25 to figure out team A. 14 times 2.25 is 3.5, but again, we can't have half games, so we're going to have to round that up to 4 games. So that's for team A. Now we need to figure out how many games are that for team B. So team A, we got our mark at 60%. Here's our mark here at 65% for team B. Now, it doesn't look like they have any games above that, but it does have one game at 65 points or more, because remember, it's going to have a different number of points in each of the team's games. So we know that that 65, that upper extreme, is going to stand for one game. So we're going to have team B's mark as one game. Team B, 1, and team A has got 4 games, so 1 plus 4 is going to give us a 5-game total for the answer to that question. Now let's take a look at example C. Example C says the males and female teachers at Mountain View School recorded the number of years they have been teaching at the school. The box plot summarizes their data. Which statement is false? So we're going to be looking for the thing that is not true. The only way to do this is to go to each statement that we have and compare them against the graph to determine if it's true or false. So let's start with A. A says the teacher with the least number of years teaching is female. So we're going to go to the end of our graphs here, or our lower extremes. Our male lower extreme is 5. Our female lower extreme is 3. So that is true. The teacher with the least number of experience teaching is female because 3 is less than 5. So our example cannot be A. Letter B says the range in years teaching is greater for male teachers than for female teachers. So we're going to have to figure out some math here. We're going to start with our male teachers. We're going to be looking for the range. So the male teachers, the upper extreme is 25. The lower extreme, as we just talked about, is 5. So 25 minus 5 is 20. So they have a range of 20. Now we need to do the female teachers. So they have a range starting at 24 for their upper extreme. And as we just talked about, their lower extreme is 3. So 24 minus 3 is going to give me 21. So the range in years teaching is greater for male teachers than female teachers. That doesn't appear to be the case because 20 is less than 21, which would make answer B false and the thing that we're looking for. Now let's just check C and D just to make sure that we've got our answers correct. So letter C says the difference in the maximum number of years for teaching for male and females is 1. So taking a look, we know our maximum now is 25 for the men. We know our maximum for the women is 24. So 25 minus 24 is 1. So that statement is true. Letter D says the median number of years teaching for female teachers is 2 less than the median of male teachers. So let's take a look at our two medians. The male teachers is 12. The female teachers is 10. So if we do 12 minus 10, we see that is 2, which in letter D says the median number of years teaching for female teachers is 2 less than the median, which is what we found. So that statement is also true. So yes, B is our answer. Now let's move on to example D. Here at example D, it says Colin caught 15 fish in each of the 2 ponds on his ranch. The box plot summarizes the lengths in inches of the fish from the pond. The length of the fish from the willow pond have a, and we're going to try and figure out which one of the statements are true. So again, the only way to do this is go to each statement and figure out which one is correct. So the first one says that the fish in willow pond have a greater range than the lengths of those in Taylor's pond. So we're going to have to do some math first. So we're going to have to figure out the range of willow ponds, which we can see is at 16, 17, 18. And we've got a 5 for our lower extreme. So we're going to do 18 minus 5 for willow pond. 18 minus 5 is 13. That's the range there. Taylor pond, we're going to be doing 20 as the upper extreme, 5 as the lower extreme. So 20 minus 5 is going to be 15. So a greater range from that of Taylor's pond does not appear to be the case because Taylor's pond is 15 and our pond is 13. So that is not correct. Letter G says the median is equal to 12 inches. So taking a look at Willow's pond, the median does equal 11 inches here, as we can see on our graph. So that is not correct either. Looking at letter H, it says that mean equals to 20 inches. Now this is talking about finding the average. We cannot find the average using a box plot. So that's another thing that we now know. We can't find mode, as we talked about at the very beginning of these notes, and we can't find the mean given the graph that we have here. In order to find the mean, we'd have to be able to add up all the numbers and divide by the total numbers that we have. And since we can't clearly see each individual piece of data, we cannot find the mean. So letter J says lower quartile equal to the lower quartile of the Taylor pond. So we need to see if the 2 lower quartiles are equal. In Willow ponds, the lower quartile is 9. And at Taylor's lower quartile is also 9. So letter J is correct because that statement is true. That brings us to the end of these notes and the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub. And we will catch you in the next one.